Hey everyone, so I'm Madhur Gupta. I'm a developer at Push Protocol and I've been working on the push video side of things for quite a bit. I'm here to show you a demo of Push Video SDK and how can you use it on your React app, and you can leverage Push Video, which is a completely decentralized wallet to wallet video calling solution on your next app. Alright, so for this demo, we'll be working with this UI. So I've added a Rainbow Kit. This is a Next.js app, so I've added Rainbow Kit to it, and then it has got two input fields. So first is for the recipient address, the other is for the chat ID. This chat ID is the push chat ID. So this demo assumes that the sender and the recipient address, that is your address, and then the address you put here, have a push chat between them set up already prior to setting up push video. Alright, then we have got certain buttons, then some more data related to the video and audio streams, both local and incoming, and then certain placeholders for the actual local and the incoming video. Alright, so before starting with the code, I would like to point here that docs.push.org contain all of our latest documentation related to everything we create at Push Protocol. So for video SDK documentation, you can go to docs.push.org/developers and then push SDK, then SDK packages and details, the REST API, and for video. So this is a detailed documentation which explains everything that I'll be covering in this demo. Okay. So coming to the code, this is essentially a Next.js app in which I've added Rainbow Kit and Ethers as a dependency and style components, but you can of course use your own CSS solution as per your liking. Okay. So this is the index page that I've added. The first thing that I'd like to take you to is the initialization of the push video class. That's the first step that you need to do. So in order to store it, we'll be creating a React ref like this, and we'll store the video object on the current property of this ref. The next step is to create a React state. This state would be responsible to store all of the video calls data onto it so that you can use it easily in your React app. Now, next, we need to initialize the video call object. That I'm doing in a use effect. So basically, we create an object of the video class. This class's constructor requires the signer, the chain ID. So Ethereum is one, I mean the mainnet, and then Godly is 5, and likewise for other chains. The decrypted PGP private key, the environment on which you are doing the video call. So this could be dev, this could be staging, this could be prod. Right now I have set this to dev, and then set data. So set data is essentially the React state changing function I showed you earlier. Yeah. So in order to get the decrypted PGP private key, you can call push api.chat.decrypt PGP key, and then you will get the PGP private key, which you can use here to initialize the video object. Okay. The next thing we'll be looking at is basically how to fire a video call request. So let's say you want to call someone, then the first thing that you'll do is to initialize the video object. The second thing you'll do is you'll fire a video call request. So to do that, we'll basically set the data on the video call object. So as I mentioned earlier, video object ref.current holds the video call object that we created, and on that we have a set data function. So this set data function is essentially responsible for manipulating the video call data both on the React side of things and as well as on the class side of things, the things which are internal to the class. Okay, here I'm using immerse produce method to efficiently change the data and then set it. So basically, in setting a request for a video call, I am assigning the local address as my address. So this is my address basically. And then in the incoming address, I am putting the recipient address. So that would be the ref.current.value. And then the status at the start would be initialized, as we have just initialized the call. And then the chat ID, as I mentioned, this is the push chat ID between the two addresses you are trying to establish a call. Now, once this is done, we'll basically create a local media stream, that is, we'll turn on our video and our audio, and then we'll create a media stream object that will be used in the video call request that will fire in the right next step. Okay. All right. So once the set request video call function gets triggered, and we basically would come to this use effect and this logic would run. So the idea is we check if the local stream is present or not. If it is present, which we have just created right here inside of set request video call, so this would become true. And as you have also set the status as initialized in right here, so it would fire a request for a video call. So it would require the sender address, the recipient address, the chat ID, which we already have stored on the data by calling set data. So I can simply call data.local.address to access all of those values now. Alright, so now once the request method gets triggered, essentially what it will do behind the scenes is that it will send a push notification to the recipient address telling them that the sender address wishes to create a video call with them. So the next step that we need to do is to basically add the logic to receive this push notification. And for that, we'll use push sockets. So the next step is to set up push sockets. So here I have added a React hook that basically sets up push sockets. So it would basically add certain socket events. The first would be the connect, then disconnect, and the last one would be the user feeds event. The user feeds event is where we'll receive the video call notification, and this is the place where we need to use the received data on the receiver's end, right? Okay, so we would be supplying you guys this entire next project, so not to worry. And in this socket hook, it will return the push socket, it will return a boolean if it's connected or not, and the latest feed item. Okay, next we need to establish the socket connection. So that would be, if the socket is not connected, we call push socket dot connect, and in the use effects dependency we add push socket. Then finally we need to add logic for receiving a video call notification. So this is essentially a use effect which has the dependency of the latest feed item. So whenever we receive a feed item, we set it here, and then it updates and this use effect gets called. So the payload is extracted from the latest feed item. We need to search for an additional meta field inside of the payload dot data. If that is there, we basically check if that additional meta's type is not equal to push video plus one. So if it's not push video plus one, that means it's not a push video call notification, it's some other notification, right? Now, once that check gets passed, we parse the video metadata, which is extracted from additional meta dot data, and on this we have a status property. This is interesting. So basically, as we saw, when the request method was fired, right here, so the request method is sending a status of initialized to the receiver's end. So once that is getting received, we call the set incoming video call method. This is something like you get a video call notification, and on the UI, we show up kind of incoming video call modal on the receiver's end with pickup and hang up buttons, right? So let me go through the set incoming video call function now. So this is kind of similar in a way to set request video call. So we are updating the data property by calling the set data function on the video call object. So I'm adding the local address, I'm adding the incoming address, I'm adding the status, I'm adding the chat ID, and as the initiator, I'm adding the sender's address because they have initiated the call, and then the signaling data. Then I await and create a video stream as we did right here. Coming back to the UI for a bit, we basically have those buttons here, right? I showed you earlier. So the first button is to initiate a request. So on click has the set request video call function, which I just showed you. Then this one. So this is the accept request button, which is to be used on the receiver's end to accept a video call request. So once the set incoming video call function gets triggered, right? This one, the status becomes push API dot video call status, that is received, and once that is received, this button gets enabled. Now we are ready to accept the video call request on the receiver's end. So accept video call request goes like this. So internally it would basically call the accept request function which exists on the video call object. So it is kind of similar to the call of request we had right here. So it has the sender address, it has the recipient address, it has the chat ID, and adding to that, it also has a signal data property, which is data.meta.initiator.signal. I have added it to data right here in the set data call. So I'm just reusing it right away. Sorry, this one. Yeah. So once this is called, it would send back another notification. So this notification would be from the recipient's computer to the initiator's computer, and this will have status is equal to received, right? So once a notification is received with the status of video call status dot received, we call the connect handler. So the connect handler is basically the final function which we need to call in order to establish a push video call. So it's a simple one. We just call the connect function and provided the signaling data which we have present on the video call metadata. Right. Going back to this handling of the video call notification, you would see certain other uh, call statuses as well. So that is retry received, that is retry initialized, and retry initialized again here as well. So just quickly going through those. So retry received is basically for retrying the received video call request. So you can read more about this one here in handling video call retries. This explains the logic. of why this is here. So it's essentially part of the retrying logic we have on the SDK. And then this one, so this entire code, this one basically is also for the retry logic. So it's like if it's initializing retry and it's the initiator's computer, then we call the request function. Otherwise, if it's not the initiator's computer, we call the accept request function. Again, you can read more about this on this page. Okay, now we are good with the video call, right? So we fired the request, we received the request, then we accepted the request, then we finally connected the video call. Now the things that remain are, let's say you want to toggle on or off your audio and video during the call, right? So in order to do that, we have these buttons right here. Okay. So to toggle your video, you can simply call the enable video function, which is available again on the video call object, and on the state is basically the boolean value which you want to assign to video. So let's say I want to like turn on my video. So I would call enable video with state equal to true, and if I want to turn off my video, I would call it with state equal to false. So this is basically the toggling logic that I've added. Similar thing for audio as well. Now, finally coming up to the hanging up part, let's say the call is done and then you wish to disconnect. You can simply call the disconnect method of the video call object, and then your call would be disconnected. Now, lastly, here in the UI, I would like to go through the video players here. So I have added two video players as you can see. So the first one is for local video. Local video, I mean your own video. And then incoming video is the video that is getting received via the push video call. Just going through this video player component quickly. So this takes in a stream. This stream is essentially a media stream object that we have generated earlier while placing the video call. And then the local stream would be stored in data.local.stream, and then the incoming stream or the receiving stream would be accessible via data.incoming0.stream. In this video player component, it accepts a stream and then it creates a ref, a React ref, and assigns it to the video element. In the use effect, we basically listen for changes in the stream and the video ref. So whenever the stream updates, we assign it to the SRC object property of the HTML video element basically and give it the stream object we receive. And then we simply call dot play. So that starts the playback. Alright, so that was me basically explaining the code of the Push Video SDK. Now let's quickly go through the app which we have just discussed on the browser. So I've already pasted in the recipient address and the push chat ID on the right window that you see. So the idea would be I would be calling the address on the left from the address on the right. So I'm ready to call the request function. So I'll click the request button. That would enable my local video, and then as you can see on the left window, the accept request button is now enabled. That means the notification for a video call has received the second computer. When I click on accept request, it would basically fire the second notification to the right browser window, and then we would call the connect function as we saw in the code. So right now the video call has been established. We can toggle on and off our video. So if I toggle the right Windows video off, it would reflect on the other window. And likewise, I can do it for audio as well. I can re-enable them as per my liking, and then finally I can hang up. Right. Okay. So that was a quick SDK demo for push video, as well as a quick functionality demo for push video. I hope you liked it, and I hope that many of you guys would be integrating the push video SDK in your hacks in this particular hackathon. I hope you liked it. Thank you. Bye.